Okay, so this is the problem number 15 in part 1 of the lab. And the problem is 60% of the children in the school have a dog, 30% have a cat, and 20% have both, a dog and a cat. So the question is what percent of those who have a dog also have a cat? So to solve this, we will use a Venn diagram. We'll put dog in here, dog and cat. So if we know there's 60% that have a dog, the total of this plus this will be 60%, and 30% have a cat, so this plus this will have 30, but both of them, which means this part, have 20, it's 20%, so then we put 20 here. So in order to get 60, you put 60 minus 20, which will be 40, and this is the same way, so it will be 10%, because 30 minus 10. So this is the total. So 40% only have a dog, 20 have both, and 10 have only a cat. So what percent of those who have a dog also have a cat? So out of these 60, what is 20? So out of 60, out of 20, which will mean the other way around, sorry. 20 out of 60. Which will be equal to 1 out of 3. So 1 out of 3 of the people who have it.
Okay, so this is problem 31 of the first partial lab for part 1. The problem is the 6 members of the Gonzalez family are going on a flight and have gotten the rows with seats C1 through C6. In the first question, we got in how many ways could they be seated? For this, we will use a permutation formula. There will be 6 due to the 6 Gonzalez family members. P, and 6 due to the amount of rows row seats that they have, which is a total of 720 seating arrangement possibilities. In number 2, little Fernanda, the smallest of the children, insists in sitting in C1. So how many new ways of this a seating arrangement could they have? For that, we'll use another permutation formula that goes 5 due to taking Fernanda out of the equation, P5, since we took one of the seats out of the equation as well. That will give us an answer of 120 seating arrangements. Up next, we have that Fernanda wants to sit either in C1 or C6. So how many new ways can they be sitting? For this, we will combine the probability of A and B, which is basically the same, since in one of the scenarios, that is C1, we still take out one of the Gonzalez family members, that is Fernanda, and sits.
Okay, this is problem 24 of the lab. So we have that a yard that contains 18 coins consisting of 9 cents, 2 dimes, and 7 quarters. We want to randomly select 2 coins, one at a time, without replenishment. So in A, we have that. What is the probability that the first coin is a dime and the second a quarter? So we have total of 18 coins. Probability of dime and quarter equals probability of quarter times probability of dime, given that the first one was a quarter. So we have 7 over 18 times 2 over 17 equals 7 over 153, and that in percentage is 4.58. B. What is the probability that both are cents? So we have that. Probability of cents, and the second being cents also. So we have equals probability of cents times probability of cents, given that the first coin picked was also a cent. So we have that probability equals 9 over 18 times 8 over 17 equals 4 over 17, that is equal to 23.5%. In C, we have that. What is the probability of selecting coins of the same denomination? Same denomination being cents, and then picking cents, quarter, and then picking quarter, and dime, then picking dime of the same time. So we have a probability of same denomination coins being